In this video, we're going to talk about oblique asymptotes. They're also known as slant asymptotes, which they do define down here as it is also known as slant asymptote. And these are the types of asymptotes that occur when the degree of the denominator is bigger than the degree, is smaller than the degree of the numerator. So here's how you find the asymptote. You actually perform long division, or if it's possible, you can do synthetic division. And the quotient is what is the result of that division. That happens to be the asymptote. Let me just show you by example. I feel like I just stumbled over that. Okay, so degree of the numerator, 2. Degree of the denominator is 1. So we have an example where denominator is smaller than the numerator, therefore has a slant asymptote or oblique asymptote, and we're going to divide this. Now, I get to use synthetic division on this because the leading coefficient of this number is 1. If it wasn't 1, I need to use long division, just so you know. But it is a 1, so I can use synthetic division. So I'm going to take that -5 and switch the sign on it. Then I'm going to take the coefficients of the numerator, and since it's missing an x, I'm going to put a 0 in there and start dividing. So we get 3. 3 times 5 is 15. We get 15. 5 times 15 is 75, and that's 76. Now, here's what's cool. We get to actually ignore the remainder. The remainder actually doesn't matter. It's this part, this first part, that makes up the slant asymptote. So this is 3x plus 15. And if I put a y equals, there it is. That's the slanted asymptote. It's a line. It's just a tilted line. It's not a vertical or horizontal line. And that's what makes it a slanted asymptote or slant asymptote or oblique asymptote. Okay, let's try another one. Interesting. They actually kind of squeeze this together a little bit. Find the oblique asymptote. Let's do that really quick. We're going to take, we can use synthetic division again. So take the opposite sign of the denominator, that's -1. In the numerator, we have -1, 2, 1, dropping that. We'll have -1 times -1 is 1, which is 3, -3, -2, but I don't really care about that. That first part makes up y equals -x plus 3. There's my oblique asymptote. Now, they did take our result over here and wrote it in this form. And what they're trying to say is that 2 over x plus 1, because we're looking at long behavior, meaning when x is going to infinity, this part ends up becoming like a tiny little fraction and goes away, which is why we ignore it. All right, that's that explanation right there. And that's it. That's the end of the section. Yay. So next section, we'll talk about inverses, as you just saw.